Hello. So, for the last few days, we've been calculating probabilities of various things. And what we're going to talk about today is whether or not certain events are independent of one another. And to be considered independent, what that means is the event A, the fact that it's occurring, has no impact or effect on the probability of B occurring. So, they just like the word says, run independent of one another. Event A has no influence on event B occurring or not occurring, etc. And there's a formula that helps us assess independence. And what we're going to be showing is that the probability of event A is equal to the probability of event A given, so that's the symbol for given that we learned yesterday, given event B. So we put a condition on it. And if even after putting a condition on it, like given they play a sport, the probability that they also participate in band or something like that, if that's equal to just being in band by itself, then we consider those events independent. If they're not equal, then they're not independent. So not equal, not independent. Equal is independent. Now, the big thing that I can stress here is that please, 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 pretty please, label your work. Because if I just have random numbers scattered all over the page and I have no idea what probabilities you're setting up, it makes it very hard for me to give you any partial credit. So when I say label your work, I want you to literally say the probability of blah, blah, blah. Tell me that probability. The probability of event A given B. Give me that number. And then show me that they're equal or show me that they're not equal. Okay, so let's look at example 1. A survey of 57 sixth graders was conducted to determine favorite subjects among boys and girls. So in this case, we are calling it male and female, or AKA not male. And it's across multiple subjects. We have math, English, social studies, science, and then obviously our marginal totals. So it says, is naming math as a favorite subject independent of being male? I typically, and it doesn't matter, but I typically let whatever is mentioned first be event A, and whatever is mentioned second be event B. So if I'm going to decide if these are independent, then I need to show the probability of what the probability of math is that the students picked, and what the probability of math is given the condition of being male in this case. So probability of math, there are 18 out of the 57 people that were surveyed. And so 18 out of the 57 people surveyed is 0.3157 dot 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 dot. 0.3157 dot 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 dot. Now, the probability that they like math given they're male. So out of all the males, there are 27 of them. 10 of them like math. So 10 out of 27 is 0.37. 0.37037 dot 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 dot. Okay. It wants to know if they're independent. Well, we said if they're equal, they're independent. If they're not equal, they're not independent. And 0.3157 is not equal to 0.37037. So we would say that these are not independent. It's that simple. Okay, so you do the individual and compare it to the conditional. If they're the same, great. If they're not, then they're not. Try another one. Is naming social studies as a favorite subject independent of being female? So in this one, I'm going to let social studies be event A and female be my event B. So first, I'm going to do probability of social studies, and then probability they picked social studies given they're female. And obviously, I'm shortcutting writing those words out. So probability of social studies. There are 19 out of the 57 that like social studies. So let's find out what that is. 19 out of 57, 0.3 repeating. Okay. Probability of social studies given they're female. So go in the female row all the way to the end. There are 30 females. Out of those 30 females, 10 of them prefer social studies. 10 divided by 30 is also 0.3 repeating. So this time we were able to show 0.3 is congruent to 0.3 or equal to, and therefore we can say they are independent. All right. This would be a great spot if you wanted to pause the video and try this next one on your own. Feel free to do that. I'm just going to keep on keeping on. Is naming English a favorite subject independent of being male? So first I'm going to find the probability of English. Then I find the probability of English given they're male. Now notice I'm labeling my work. I'm not just writing random numbers down. So you should be doing the same thing when you do these by yourself. So English, 10 out of 57. 0.1754 dot 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 dot. I usually just do a couple decimal places if it's a forever decimal. You'll know if they're equal. That's essentially all I'm going to tell you. If they're equal, then great. If they're not equal, then you'll know. English, given male. So there are 27 males. How many of them like English? Only 4. Let's see, 4 out of 27, 0.1481 dot dot. So obviously they're not equal, and therefore they're not independent. Nice and easy. Nice and easy. All right. So you might be thinking, okay, cool. I don't really understand what we're doing. I'm just following what you're saying. I think it'll make a little bit more sense on the next example, what independence and what being not independent truly means, given a more substantial context to the question. Because I think I can assume that at some point in your life you've come across someone who smokes and someone who doesn't smoke. And I think we've all heard the studies out there that, if you smoke, there are adverse side effects to it. So this next study, they studied 937 people, or students in this case, and out of those 937, 182 of them had asthma. It says out of the 937 students, 395 of them reported that they live with someone who smokes. So 395 of this say that they live with someone who smokes. And then it goes even deeper. Of the students who live with someone who smokes, so out of this column, 113 of these people have asthma. So 113. And then obviously subtract and add and whatnot to find all your missing table spots. So this would be 542, 755. If I subtract over here, 282. If I subtract over here, 69. And this missing gap here is 473. Okay. So now that we have this context, we're like, okay, we have kids that have asthma and don't. We have kids that live with someone who smokes and students that don't. It wants to know if having asthma is independent of living with a smoker. So again, I'm going to let this be my event A. I'm going to let this be my event B. So first I'm going to find the probability of asthma, which by the way is the weirdest word to spell. And then I'm going to do the probability of asthma given they live with someone who smokes. Now, just knowing life, and we know that smoking is bad for you, we can probably say that, yeah, smoking might have an effect on the kids and their lifestyle and if they have asthma. So let's check it out. Asthma, there was 182 students that had asthma out of the total. If I turn that into a decimal, because that's always a little bit easier for us to compare, 0.1942 ... The probability they have asthma given they smoke. So look only in the smoking column, which is 395. Out of 395, 113 out of the 395 lived with somebody who smokes. That's pretty significant. I know it doesn't look like much of a difference, but there is a difference. All right, so 0.2860. Obviously, those are not equal. So you could say that they are not independent. And sometimes the way that I think about this is like, it's funny that we have to say that they're not independent because we have a word for that. It's dependent. That means asthma is dependent or could be considered dependent on the fact that there are smokers in the house. And it could be the reason why there's a higher cause of asthma in the house. So what we can then say, if we decide that they're not independent, write a full sentence in the context of your calculations and this problem and state your findings. Because this is higher, our conditional, given that there's a smoker in the house, and since that's higher, we can say you are more likely, not guaranteed, but more likely to have asthma if, or given, you could use either word here, if there's a smoker, you live with a smoker in the house, or given there's a smoker that lives in the house. Given you live with a smoker. Here, if we want to convert this, technically we could say that this is like 19% of all students have asthma in the school that they surveyed, right? But this one with the conditional, almost 29% of kids that live with someone who smokes have asthma, which is definitely larger. So there must be some, you're more likely. And we use the word more likely because this is higher. If our conditional was lower, we would have said less likely. All right, one more example. Nice and short today. Okay. Data enrolled. We are given a Venn diagram. Construct a two-way table given this Venn diagram. All right, which is good because I like two-way tables better. My opposing categories are Algebra 2 and sophomores. So maybe across the side, I would say Algebra 2 and not in Algebra 2. And maybe across the top, I would say sophomores and not sophomores. And I'm not going to put juniors, no offense, juniors, because, hey, you never know. You might have an accelerated freshman, or you might have a senior. So I'm just going to say sophomores and not sophomores. So let's read it. I think the easiest part of a Venn diagram to figure out is the overlapping part. Who's in Algebra 2 and is a sophomore? The ands is the overlapping part of the two circles. That's going to be where the two categories come together. Probably the second easiest spot is this floating number in the corner. Those are your not-nots. Those are the people that are not in Algebra 2 and not a sophomore. So these are your not-nots. That's what I call them. I know that sounds kind of silly. Those are my not-nots. So 956 in that corner. Let's just figure out how many Algebra 2 students there are. So I'm going to circle this out with my red pen. So this entire circle represents how many students are in Algebra 2. And the way we can get that total is add the 239 plus the 81. That must mean there's 320 Algebra 2s. So that is a marginal total. So Algebra 2, we got 320 over here. And then if I circle maybe this side, that will help me figure out how many sophomores I have. So 324 plus 81 as well. That's going to give me 405 total sophomores. And from there, we can pretty much fill in the rest of our chart. 405 and 81, this will be a 324, which you can see right here in this little crescent moon, just sophomores that are not out in Algebra 2. This little crescent moon right here, 239, is right here. Those are the people that are in Algebra 2 but are not sophomores. Totaling down, this is why I prefer a two-way table to a Venn diagram, because 239, 956, if I add straight down, is 1,195, and that is not a number that just jumps right out at me. Could I get it from a Venn diagram? Yes, but I would have to add some stuff together. Same thing with this one, 324, 956, that's 1,280. Again, another number that's just not staring at me. So I like a two-way table, and then if I add up my marginal totals, they should total 1,600 students. Whew. After all that, let's figure out if we're independent over here or not. Is Algebra 2, so I'm going to let that be event A, independent of being a sophomore? There's event B. All right, so the probability of being in Algebra 2, and then compare that to the probability of being in Algebra 2 given they're a sophomore. You should show this work. Write down what your probabilities are that you're comparing. So Algebra 2 on its own, 320 out of the 1,600. 0.2. That's a nice number. Algebra 2 given they're a sophomore. So there are 405 sophomores. Out of that, 81 of them are in Algebra 2. 81 out of 405 is also 0.2. How exciting is that? So that means they're independent. Being a sophomore in Algebra 2, no bearing on one another. If you had to write a sentence here, you could say that they are equally likely. On the previous example, we said more likely because the conditional was greater than the other one. This one, since they're the same, we could say that they are equally likely. All right, see you next time.